of Thomas Ellet van Brasch from Kartverket, the Norwegian mapping authority. So, Thomas, I think you can share your screen now. And also, please, can you share your camera so we can see you?
My screen I can share. My camera is a bit
It,
more tricky. I have
okay.
issues with my
Yes,
camera.
I
The
remember.
screens, I'm
Yeah.
afraid, yeah,
Yeah.
still have
Okay.
that issue. So
Thank you.
sorry about that. Okay, hi everyone. My name's Tom Ellet von Brasch, as Benedict said, and I work for the Norwegian Mapping Authority. Today I'm going to talk about an internal project we've had for the last couple of years in Kartverket, and just a little bit at the end about sort of future work and work going on in other places in Norway. So, yep, let's just start right on this. So the project I'm talking about is making administrative units available as linked open data. So it's the only data set we have at the moment that's available. And if I can just, there we go. The project started off through a request from DIFI, which is the Norwegian Digitalization Agency. What they wanted to do was to geocode the metadata they have in something called the Felles data catalog. That's the common data catalog within Norway. They wanted to geocode this metadata in a better way than they have done in the past. So the methodology they used to use was simply tagging the metadata with a string for these administrative units. Which was nice enough, but it obviously doesn't give too much extra information. What they really wanted was a link that could give the user more information about the administrative unit that the data covered. And they wanted to be able to, instead of storing that data themselves, they wanted to link to that from the authoritative source, which is the Norwegian Mapping Authority. So once we got that request, we started looking at it. I should also mention that this request came on the back of quite a large project called the County and District Merging Project. Norway in the last few years has reduced the number of counties and municipalities quite drastically, almost halved the number of counties and reduced the number of municipalities by, I think, over 150. So because of all this dynamic movement and change, they wanted DIFI wanted to link to our authoritative data as we maintained it and have that dynamic link. So we started on the project and we wanted to focus on four main areas. The first was a simplified data model. So one issue we have with many distribution systems we have actually is that a lot of our models are quite complex. They're management models, not really suited to distribution so much. That's especially the case when you're looking at RDF and linked open data. So we needed to come up with a more simplified data model so that non-GIS experts could understand the data they were looking at. Second area was ontology. Once we'd come up with that simplified data model, we looked at whether it's possible to automatically derive this from the UML model, but that turned out to be a bit more problematic, so this was manually made. Then we need to look at the dereferenceable and stable URIs, something we don't have for our data. We have some data sets with UUIDs, but most of our data sets only have local IDs. And it's only in the last year or so that we've started a registry for naming and domains. And finally, we obviously had to distribute the data according to the RDF specification. We decided on 3 different endpoints: a Sparkle endpoint for sort of full professional access, if you like. But obviously, those who have used Sparkle know it's a little tricky. So we also wanted a REST API so that non-experts could easier get access to the data. And finally, we wanted some kind of HTML or doc representation so that the public could easily understand and get access to the data. The infrastructure we used for ontology creation, we used a tool called Protégé, which is open source. Very powerful, a bit of a steep learning curve, but it goes fine. So once we'd created that ontology, we published that in our RDF Kartverket domain, make it accessible to everyone. And then we could start on actually creating the data. So for this, we used a plugin to Project A called OnTop. It's a little bit old. I'm not quite sure about how it's being maintained and versioned now, but at least it's still working for us. And what OnTop allows you to do is to access your source data, which is the number 3 step in this picture, and then create mapping rules from your source data to your ontology. So that creates a turtle file, number 4 here. And from the mapping file and the source data, you can then materialize the triples. Once you have those, it's an easy job to upload those into your graph store. So we're using Virtuoso as our graph store, and that has a bulk uploader, which we can use. And as I mentioned, we also wanted to create this REST API for easier access. So we have a Swagger endpoint. Just a little bit about the URIs that we're using. So we use a fairly standard pattern for those. We have a domain, a dataset name, a feature type, a resource type, and a local ID. The ID caused us a few issues because the local IDs we have were at a geometry level. And this meant we had multiple local IDs for some units. So there's some municipalities and counties with exclaves. So that resulted in multiple local IDs. So we just used concatenation to create a UUID. The data flow, as I already mentioned, the source data was in PostGIS. Nearly all our source data, vector data, lays in PostGIS. We used OnTop, but we also have been using Karma for other projects, predominantly a European project we're involved in. Both have their strengths and weaknesses. And
2 minutes.
2 minutes, thank you. And as I mentioned, we're using Virtuoso as our graph store. We're using the open source version. It does pretty much everything we need, and it handily comes with several tools, one of which is a built-in Sparkle endpoint, which is still available, and we've hardened that endpoint so that there's a timeout for very long queries, and we've limited the number of results coming back to, I think it's 10,000. So the access, talked about the Sparkle endpoint, which we have. We have, as I mentioned, the Swagger API, which runs directly over the Sparkle endpoint. But we also have this HTML doc representation for the public. So this is we've made this internally, and this is simply created dynamically through a proxy. It's fairly similar at the moment, just a simple mapping client in there with the attribute information. We hope to be able to work further on that in the future, perhaps link it to other data sets that we might create. So very quickly, it was requested, this information, by DeFi, but we're also using this internally in our metadata catalog. So on the left-hand side here, you can see the GUI editor we have when we create the metadata, and this is where we can you can use the API, the REST API we have here, to encode the metadata. So on the right, this is the result of that, and you can see that we have these links for the administrative units. So you can say that this metadata record is encoded or linked to these administrative units, and obviously when the user clicks on those, they get this additional information here straight in the HTML. So this is obviously extra information. This also, we've tagged this information with the schema.org attributes. So then in theory, this can be indexed by the search engines as well. Versioning, I should mention more about, but this data set is fully versioned. So we have links from one unit to another, the historical versioning. I can give more information about that if people are interested. And quickly, future plans. Hopefully more data sets, place names, and transport networks. We're not sure if we're going to go with the full linked open data infrastructure, or if we might just use parts of that. So we might go further investigating the use of graph stores, certainly URI, UIDs, and the search optimization will be an area we'll look at. And also we're going to be working more with the OGC API for features, through which we're considering having JSON LD as a standard format. And if I just have another 20 seconds, national work. Difficult to say too much about this. I'm not too clued in, but at least there's the SINTEF, which is a research institute in Norway. They're constantly doing work on linked open data, especially around open transport data. Norwegian road authorities, I've been told, are doing work, but I haven't been able to find any documentation. And there's also some data sets from new local municipalities being made available. But as I mentioned here, in Norway, it's a little fragmented and patchwork coverage. Possibly a result that there's no real central national driver at present. Okay, that was it. Thank you very much.
Thank you very much, Tom. There is a question from several questions, but one from France on the version identifiers. And since you say you could talk a little more about versioning, do you use versioning?
Yeah, that's yes, no, that's true. In the URI pattern I showed, I didn't mention the version ID. So for versioning, what we've done is simply attach a date to the end of the pattern. So I can't categorically say that's the best way of doing it, but that's what we've done, so that the historical version changes the UID, the URI if needed. So, for example, Ringerike municipality, if the geometry changes significantly, we will create a new URI for the new entity and encode the old URI with the end date, if you like. So that's the way we've done it.
Okay, thank you very much. We will now listen to the next speaker. So it's sorry, it's a bit fast and not many time for question. So the next speaker is Pasquale Di Donato from Swiss Topo. Pasquale, if you can share your camera, and then you're a presenter and you can share your screen. Thank you.
Okay, can you hear me?
We can hear you. We can't see. I think we will soon. Yes, we can see you.
I try to share my presentation. Do you see the presentation? I hope. Yeah.
Yes.
So, good morning, everyone. My name is Pasquale Di Donato. I'm working as a project coordinator at Swiss Topo since 8 years now, and specifically with linked data since almost 5 years. I would prefer to switch off my camera during the presentation because of some connection issues. I'm at home, and sorry for that. A few words on Swiss Topo. Swiss Topo is the Federal Office of Topography in Switzerland, and it has the legal mandate stated in the Geoinformation Act from October 2007 to operate and maintain the federal spatial data infrastructure. And KGiS, there's a division I'm working within. It's a division of Swiss Topo, which is coordinating all activities at federal level, dealing with the geoinformation in general and specifically with the federal spatial data infrastructure. As said, we started working with linked data in 2016 when we launched a little project in a form of a proof of concept with the main objective to build internal awareness and knowledge. We decided to try to use administrative units as a test data sets and providing versioning also as yearly snapshots. We identified the non-GI experts as our intended audience, which means for us that we have to take care of improving discoverability, reusing existing and standard vocabularies, and use WGS as coordinate reference system for the geometries. We got good results from this project, from this proof of concept. So we decided to put it into production, and we released the system in March 2017. We basically are using these technologies. We use GDAL, OGR for spatial data preprocessing, meaning we transform the format to CSV and coordinate transformation conversion, for examples. Then we use Starcall for the RDF serialization. We have Virtuoso currently in the open source edition as a triple store and for serving the Sparkle endpoint. And then we have a linked data front end, so the URI dereferencing part and the content negotiation part, which is implemented with 3Feed, is an open source software developed by a Swiss community, a Swiss enterprise. The data we published at that time in 2017 were the administrative units as a yearly snapshots for 2016 and 17, and public transport stops. Currently, so we have 3 main components published. Public interfaces, we have a Sparkle endpoint and the Sparkle client. And we also have a search tool, basic search tool. Today we publish the administrative units from 2016 to 2020 and already working on the next update for 2021, public transport stops, hydropower plants and road traffic accidents. This is an overview of the system, of the architecture and the publication process. As said, we get some source data from the data providers. We pre-process the data and transform to CSV, Starcall for the RDF serialization, upload in Virtuoso on open source, and then set up the linked data front end that takes the information from the Sparkle endpoint and make them available to the users. As already said, we try to reuse vocabularies as much as possible. We are missing, in my opinion, a generic and lightweight governmental vocabulary in Switzerland from some Swiss-specific definitions. We are trying to work with other federal offices so to create this kind of vocabulary. By the way, we also think we have issues with this configuration that we would like to address with a new setup. So we have a double publication pipeline. The main one in the top of the picture for the spatial data infrastructure, and the bottom part is for linked data. So actually we have a double pipeline publication process. We have a redundant data storage, and this process, which is actually almost everything is manual done, is quite inefficient when it comes to publish dynamic data, such as, for example, we will publish next year the official register of addresses, and this contains over 2 million records. Is updated daily, meaning that we have to generate at least 15 million triples and publish them daily. So the current configuration is not enough good for this. It's quite inefficient. So actually we are testing now a new processes, new configuration. We are trying to synchronize the publication so to avoid data redundancy. And the idea here is to ingest data once, put them in a data layer, and from this data layer serve different needs. For the linked data part, the idea here is to generate triples at runtimes by configuring RDF views via R2RML mapping in Virtuoso. For that, we have been obliged to switch to the Virtuoso commercial edition, because the open source one does not enable to create ODBC connection to external data sources. And as said, we are testing this new configuration infrastructure with two important data sets, and namely the official register of addresses and the official register of roads. This
2 minutes.
Yeah,
Sorry.
thank you. This will come, I hope, first half of next year. I guess it's all from my side. You can contact me for offline question also if you want to this email address, and grazie per l'attenzione.
Thank you very much, and sorry for interrupting you.
No
almost
problem.
at the end. I have a question on the versioning, the synchronization system you propose,
Yeah.
and it's during the synchronization. If one source is updated, do you then have to reload everything on the fly?
No, we don't have to
Or
reload
just
anything, because we just need to configure the R2RML mapping in Virtuoso. We create
yeah.
RDF views. These are not how to say, these are not stable graphs. These are created at runtime. So then when there is a request to the link data front end, then this request is transformed to SQL. The request is sent to PostGIS. PostGIS is giving back the answer in SQL, and then Virtuoso is retransforming this SQL into Sparkle. So at least you don't have to touch anything unless you change the model of the data or something like this.
Okay, thank you. And
yes,
also,
sure that this needs the commercial edition. I'm seeing here a question. The free version does not enable to connect to external sources.
okay, and doing this, did you have specific clues or feedback on the URI policy? Because I see it's a strong concern for the participants.
We don't have a national URI strategy. We just defined one internally for us for the federal spatial data infrastructure, which is quite similar to the ones presented by Tom for Norway. So we have kind of category and data theme, and we use a local ID, or yeah, it's very similar to the one presented by Tom. There is no discussion about URI strategy at national level in Switzerland. So
Okay.
I did say I don't think it's a crucial point for me, URI strategy.
Maybe for versioning? So
for versioning, we do exactly as Tom said. We use the we have yearly snapshots for the administrative units. So in a way, we have an unversioned resource. For example, municipality of Bern, and in here we use a property like has version, and the has version, the URI change. So we just postpone the a date, the year.
Okay.
So for example, the local ID for Bern is 3451, and the version 2020 is 351 2.2020.
Okay. So thank you very much. We will now go on to the next presentation, and we will be listening to Falk Würriehausen from KGiA in Germany. So Falk, you can share your screen, and if you have a possibility also to share your camera, even if you want them to shut it down, so we can see you at the beginning. Okay. Falk, we can't hear you. I don't know if.
So can you hear me?
Yes, we can.
Yeah. Okay, thank you. Okay, thanks, Benedict, for the short introduction. Hello, everybody. My name is Falk Würriehausen, and I'm from the Federal Agency for Cartography and Geodesy. We are located in Frankfurt am Main in Germany. And in my presentation, I will show you some activities in linked spatial data, which we have initiated as a part of our spatial data infrastructure activities in Germany. In my presentation, I will give you a short overview of our project and our project task. Our project objectives are to design and testing of a linked data architecture in the spatial data infrastructure in Germany. And here are some tasks I will show you. The first task was the data transformation from GML shape formats to RDF. The second one, the data management concept in triple stores. We have research of that. And the next one was the development of a new front end for spatial linked data. This is our project purpose. We call it GeoPuppy. And the last was to linking the SDI Germany to other linked data sources like Wikidata and so on. First of all, our project started at the beginning of the year 2020, but it's a new project in Germany. The first task was the transformation of existing spatial data sets in our spatial data infrastructure in Germany to the linked data RDF serializations, for example, the RDF XML serializations, turtle serializations, or the N3 serializations. For that, we developed a concept and transformation tool for standard-based data, for example, our national standards XPlan GML and XErleben GML. And also our Inspire GML datasets should be transformed. But also we support other formats like shapes prototypically. And it's a pure syntactic transformation, but it enables us to store it in so-called triple stores, which serves as a knowledge base for our linked data sources in Germany. For the data management, we decided on the triple store GraphDB from OntoText because it's already supported the GeoSparkle extension. The triple store GraphDB has been prototypically set up in KGiA since the end of May in 2020, and it's available under the following URL. LD for linked data, kgia.org. It's our spatial data infrastructure in Germany website /GraphDB, and that's the front end of the GraphDB. The access to the RDF data is also possible with the graph visualization of GraphDB. It makes it very easy for the users to check their data and structures, and the added value can be seen very quickly. What is linked data and what are the benefits of that? GraphDB also offers a Sparkle interface in which both Sparkle and GeoSparkle can be queried. Here you can see a query where I have transferred an Inspire data set record to RDF, with which a query for the subject predicate object. And here you can see the triple with the ID of our Inspire data set, the name of this object, and the well-known text geometry as a point representation in the Sparkle query. Next step was in this project was we are looking for a front end to provide our KGiA linked spatial data sets. There are some GUIs or graphical user interfaces online, but without explicit consideration of the spatial reference. And in our project, an additional representation in the map and the fuzzy search was desired. Our project partner, the University of Mainz, has developed a geo-extended version of the front-end Puppy. Puppy is an earlier front-end of DBpedia. And here you can see the first implementation of GeoPuppy with data from DBpedia, with a photo of the city of Mainz and a map representation of the coordinates. And now we use this GeoPuppy version and make it with an own style and published our own data in GeoPuppy. And it really works So here you can see an example. This is the location of the Federal Agency for Cartography in Geodesy in our linked data client. This data set is linked to Wikidata property concepts and displayed in our own GeoPuppy instance of KGiA in BKG. Above, you can see the label of the data set. You can see our fuzzy search for the content and the map with the location of the BKG in a user-friendly map. And we have also linked to Wikidata property concept. The data is provided by us, for example, the telephone number, the email address, or the website. And if you want to look to this example, below is the link. It's a simple ID concept, which a centralized linked data service, which are ID and which the namespace of our federal agency, and it's a point of interest, and the last is the local ID. So I saw we start in 2020, so that are our first results, but we have some conclusions of our first activities with linked spatial data in Germany. For me, it's possible to set up a linked data compliant architecture, which has already been implemented as a prototype within the KGiA. For me, as project leader, the GraphDB data triple store, it's suitable as triple store for provision of the linked spatial data sets in the project. GeoPuppy, this is a newly developed geo extension based on the Puppy version of DBpedia, could be implemented in our linked data architecture and the service in BKG. And current works in the project are, for example, to support more vector geometry formats like GeoJSON, GeoJSON LD, KML, GML, and so on. And also EPSG coordinate reference systems will be implemented in GeoPuppy in future. So, and if you want to look at this GeoPuppy, you can find the community edition on the GitHub webpage of the University of Mainz under this link. So this was a short overview of our project in Germany. Many thanks for your attention, and if there are any questions, feel free.
Thank you very much. It's impressive because it's very young, as you say, but already lots of results. And there is a question on, do you have plans to move from this experimental project to production level?
First of all, it's prototype implementation. And but the first results are very hopeful that we can use it not prototypically, so also productive in Germany. But the project is not in the end. We will make some more research in this case, maybe in end of 2020 and beginning of 2021. So I will hope if we get more good results and good user feedback, we get it productive in the middle of next year, maybe.
So we have time for one more question. And when you say user feedbacks, actually, what are when you say the user, I imagine it's the user from the task you mentioned at the beginning, the task the prototype had to support, and who are the users who are performing this task?
We have a small project group in BKG. I'm the leader of a working group architecture in SDI in Germany. And our working group are many participants involved, and they get more user feedbacks also in the federal states in Germany, not only in BKG, but also in the federal states. And it's a process, but the first results are very positive and hopeful to make this research also at the predictive system in the middle of next year.
Thank you. And also, one last question: is there some quality checking in the whole infrastructure or in your plan for the future?
Now, actually, it's only a simple transformation from our national data sets in GML format or shape format to the RDF. It works more nearly automatically. It's only a syntactic transformation. And maybe in the future, it could be helpful to get some processes for the quality check also of the data sets. We can use also more linked data sources. For example, the linked geo data sets, OpenStreetMap, for example, we can use the Sparkle endpoint, or we use wiki data sets for our quality control of our data. It could be a good research next year, hopeful.
Yeah, for sure. Thank you very much. And